Yeah, so the focus for today is to try and talk about if you are to sort of prove yourself that you're an expert in AI, if you're applying for jobs or within your sort of firm as well, what sort of um, projects that I may do to show my competence. So I think as you may have seen, like AI tend to have like sort of evolved a lot in different sort of domains, and you might have seen quite a lot of projects and different kind of applications with different kinds of technologies sort of come about. So my name is Aki. So my background is in machine learning. I've been doing this for the last 12 plus years. Done a PhD and a postdoc previously, and I see few familiar faces that have joined like previous sessions as well. It's amazing to see you guys. So currently I'm running a consultancy firm called Snapdrum, which helps build end-to-end AI solutions for firms out there, mostly on the North American sector and also in the European sector. So yeah, so we're going to talk about what how we can sort of make sure that you can prove your AI competency if you specifically have like 30 days to do that. So that's the main focus. So we're going to talk about a framework called PACE, which is system that you can use to build products in a way that it shows your competence. And then we'll sort of go through that framework and also we'll look at how that framework sort of through a few examples. So we've got like few AI project examples that you can sort of work on depending on your sort of interest. And towards the end, we have a bit of a Q&A as well. Yeah, and feel free to sort of ask questions. We don't have a lot of technical sort of focused implementations today, but it's mainly about sort of thinking through this framework. Yeah. So what is PACE? So PACE is not necessarily a checklist. It is a framework that helps you think about how to build applications that um, yeah, I think Kimberly got a question. But yeah, I'll come back to that in a bit, Kimberly. I think so. I think so. Pace. I'll go to details in the next slide. So it helps you to sort of think about when you start building system, how we can sort of ensure that you cover almost all the areas of the application that you're developing. So it's not like a one-off system. It is a continuous system. That's why it's got a loop. So it sort of goes on iterations so that you can sort of help improve your product. So this is what I mean by PACE loop. So P stands for problem, and so define the core problem that drives the need for solution. So you may have personal sort of a technical problem that you need to get solved, or within a business as well. So that is the first sort of entry point to this loop, and then you sort of think about the architecture. What would be the system that you're going to build to solve that problem from a technical point of view. Then you make sure that you collect the right kind of evidence. Uh, Notice I've switched CNE. So I'm gonna move this to here. Yes. Um, yeah. So the next is constraints. So like figuring out, so you build up architecture. Now you just figure out like what are the sort of the boundaries, the boundary conditions, right? The cost, and if you're using different types of models, like the level of reasoning of those models, the infrastructure sort of logic, the privacy constraints. So you have like a lot of constraints within your application. So you need to figure out where are the trade-offs, whether it's the privacy or whether it's cost aspect. So that is the next step. So when you build architecture, so there's a bit of a back and forth between like sort of the architect and constraint. But when you start thinking about the architecture piece, you'll start developing the system as well. So my sort of experience has been the sooner you can sort of build something, an MVP, starting from your problem, at least at the architecture level, that's the best place to get started so that you have something to show to your users or yourself and figure out what are sort of the missing pieces and you can sort of iterate and improve that. Then you sort of finalize on the constraints and you start building that. The next step is the evidence piece. So you want to make sure that you have the right kind of information to sort of pull the metrics that is needed to figure out if your system is working properly. So you sort of feed that back into the system again, and you sort of redefine the problem a bit and react to the system, and you start going on this loop so that improving, so that the metrics that you have set in your sort of system sort of can get captured. So this is like the general sort of the sense of the pace loop, and like we will sort of look at like some examples next, how this would sort of plan out in a sort of real life setting. Um, yeah, I think Kimberly, to answer your question, where's the best place to showcase these projects? I think obviously GitHub is a really good place. You should like it's a great place to host your code, and then you also add the documentation, things like that. But also, I think one of the things I suggest is like to get something deployed, whether it's to Netlify or whether it's through some sort of a like Vercel, like where you can sort of deploy even like a demo that you can sort of showcase that the system works really well. So those like visually sort of appealing demos gonna take go a long way. With AI, you can sort of build these front ends of the visually pleasing sort of the UI much easier as compared to like few years back. So because that I would also think about that aspect as well, not just the code and the documentation, but how do you sort of like put it out there, whether you want to share it on LinkedIn, whether you want to share it on Twitter, or just record something and put it on YouTube. So those kind of things are also important, not just the technical side of things, but how do you sort of communicate your product. So yeah, that's my sort of 2 cents on that question. So how do you sort of think about like each sort of stage? So you got the problem stage, system architecture and the constraints, and then the evidence collection. So very simple. The first one is well, the step is simple, but it could be difficult depending on the problem. So it's the requirements gathering stage where you sort of think about, okay, what is the problem I'm trying to solve? And then like, so depending on talking to the right kind of domain experts, you define the problem. So it's not just a straightforward do X using Y. It's more about we have some sort of issue and we need to solve that. And then there are these kind of parties involved in this problem, and we need to make sure that it is that everybody feels comfortable, and everybody this problem is solved, and then you need to figure out like what are the metrics, like what are the success metrics going to look like. If it is something to do with let's say some sort of a project process that is so much delayed, like so they take like let's say 2 to 3 days to do certain tasks at a business, and you can sort of use time as a metrics where if you can reduce the time that is needed to sort of finish that workflow, that is a really good metric. And so the problem definition is not just the problem itself, understand the users, and trying to sort of define the success metrics. And that's the first step. And then you bring in folks who understand the technology piece. You start building the system architecture. You map it out, and you make sure that to define what sort of components are needed, and also define like the data flow, and then figure out the development strategy. So this is where software engineering and engineering comes into play. And then you sort of while sort of doing that, you sort of go to the next stage where you sort of consider the constraints like the latency requirements, the cost implication, the reliability and safety aspects, and how do you sort of make sure that architecture sort of fulfill those sort of requirements. And you do have sort of a bit of a loop from there sort of coming back. So the system architecture get redefined a bit depending on these constraints and the discussion that you may have with the stakeholders. So even though this looks like a linear sort of steps, there's a bit of a back and forth, but these are like the core sort of steps within this. So as you can see, this is a lot more different than like doing some dummy application using Lovable or something like that, where you build something really nice, but it may not be sort of based on actual problem. It's something you do it for fun. But given that everybody can do this right now, the bar has been raised a lot. So now you need to sort of show from sort of engineering point of view that you can sort of actually do the problem solving piece, and you can do the system architecture piece, and also sort of reason out about the constraints, because that's where the best kind of sort of engineering comes out, to show that you can trade off between different technologies. You can say like why I use opposed to OpenAI models and why I'm using Gemini. So likewise, so it's very important that you understand the constraints and you make very conscious decisions, like when you're selecting different kinds of sort of tool sets. That's where the best kind of sort of skill set come out, and obviously need a bit of experience to do this, but the more you do, you realize that this your sort of system constraint muscle gets sort of improved. So that's where I'll put a lot of sort of emphasis on, like that sort of that shows your expertise and how you think about problems. And the last bit is the evidence collection, that you have the right kind of observability set in place within your system, that you understand the health of the system, whether it's like something like Langfuse, where you can keep track of how the prompts work, or it's like CloudWatch and AWS that you keep track of logs. So you sort of might have a graph on a dashboard that helps you sort of have this information. So everything sort of loops back to that pace loop we spoke about, where that evidence sort of like implies and gives you the information that is needed if the system is doing well, if you need any sort of improvement, if people are not engaging with the system, that's a really good signal you can pick out from the log. So stuff like that, if something breaks down, you can do that as well. So that evidence piece sort of feed back into the so the loop, and you go on this loop until the system is good enough, and you set your own parameters, like what the system like good enough looks like at this success metrics stage from the initial state. So that's how this pay sort of structure works. There are different variations of this, but this is something I sort of feel comfortable. I've seen this a lot in industry. So these are some projects, sort of like still not super sort of concrete, but you can build something using these, so that where you have the problem, like a project that is a relatively grounded on project problem, and then you have the tech stack, the infrastructure, and the key metrics you probably need to track to show that this the project is working. So voice support triad agent, so that's sort of like automate initial handling of support calls. So this is also relatively easy to build as it is. But if you think about looking at the tech stack or the infrastructure piece, it's going to be for the rest of you, type in what cohort. Um, so if you look at like voice agent that you can build, so if you can think about looking at the latest sort of voice agent development, it's relatively easy to build voice agents. But if you base it on a specific tech stack, you can sort of go a bit deep. Like either you pick either 11 Labs or use something like Google sort of tech stack, like speech to text, things like that. Even OpenAI has their own tech stack. You can use some of these sort of models and layer it in a way that you can create a voice agent, and then you sort of deploy that in one of the infrastructures. Sort of whether we had a fast API or a Node.js server, or you deployed on AWS with that. And you can connect Twilio as well. So you can do a lot of infrastructure play here as well. So doing each and everything with right kind of reasoning is a really good example that you can sort of showcase that you have thought about this, and definitely shows that you understand how AI works and like how to sort of deploy that. And also if you think about like how the scaling works in this, like how do you handle like a lot of concurrent calls. So if you need to put right kind of scaling capabilities so that it can sort of spawn out enough nodes that you can handle this. If you look at the key metrics for a project like this, I'll think about like the routing accuracy, escalation rate. Like for example, if the agent can't sort of handle this and it needs to escalate that to human, the lower the number of escalation rate, that's a really good thing. End-to-end latency, if you look at like the stack of the voice agents, ideally it needs to be 800 milliseconds or less. Otherwise, with the more latency it has, the humans can understand that there's a delay in the conversation and doesn't feel like human. So because of that, so you need to track the latency as well, and cost is very important, because large language models with voice agents are quite expensive. So you have to like keep track of cost, how to reduce that, etc. So there are multiple key metrics for voice agents that you can track, and you can sort of try and sort of improve them as well. So the second project I would sort of suggest is something like multimodal document review assistant. So because it has the multimodal aspect, and also sort of you can sort of think about how to sort of like reduce hallucinations, etc. So this is like relatively simple to build, I would say, compared to voice agent, because you can use things like Gemini, GPT, vision models to sort of analyze documents, and you can do extract information from invoices and all kinds of documents, handwritten documents, sort of extract that information and push that information to a database or some sort of a data infrastructure. So that is a very practical problem. If you look at any number of organizations, there is a component like this where they have to sort of digitize sort of documents a lot more, because we live in a world that we have still physical documents coming in, and businesses also operate both in physical and digital space. So you have to get them to a single sort of a database to operate. And this is like one of the most common sort of applications. Even myself done quite a lot of consultant work in this space. We have like built like use Gemini to do this kind of extraction work and sort of help companies sort of have this the data processing step done much faster and much cheaper, because Gemini is like a relatively cheap model compared to OpenAI. So you can do a lot of processing like 1/10 of the cost compared to OpenAI. And you can sort of build something like this. And then from metrics point of view, if you think about like extraction precision, and how much of extractions were overridden by the human in the human who checks this, and also compared to the previous sort of mechanism by humans doing this, like what's the time gain, like how much of an improvement that this has sort of done. So because it's important, because there's a cost to AI, so you need to compare that with like how much, if you get a human to do it, like what's the cost. So from business point of view, whether this actually sort of improve the cost. So you need to track those metrics to say that your product is good enough for a business use case. Um, Third project I want to highlight is multi-agent research assistant. So this is relatively easy to build. You can use something like NA10, even OpenAI sort of agents. Claude has as well. Oh, but if you start from scratch, you can sort of build like a retrieval agent that sort of uses one of these models with some sort of vector database like Pinecone or VV8 to create this multi-agent research assistant. And you need to think about how to sort of pick the right kind of model and how to deploy this as well, because you might need a reasoning model that can reason about the research aspects of the problem. And also uh, Ray from my team shared a link on the chat. If you guys are interested, feel free to join. We do have a WhatsApp community that sort of shares and talk about AI a lot. Latest jobs and latest information is there. So yeah, I mean, thanks Ray for sharing that. We don't want to share that at the end, like she shared that right now. Thanks a lot, Ray. And Yeah, I think like the metrics that we track here it would be around the answers consistency, the citation the correctness of the citations, latency per query, because like being a multi-agent system, if it takes a lot of time, it may be costly and also not the best user experience. You need to keep track of these. You can use something like Langfuse or some sort of a observability tool to keep track of this information relatively easily. So that's how I would like sort of scope this project that helps anyone sort of build a multi-agent based like research assistant, like something like deep research from OpenAI, which can be easily done by yourself with tools like Claude, N8, OpenAI, etc. Um, the final project I suggest is also a voice agent project, voice first scheduling assistant. So this sort of goes into not just the voice layer, but also thinking about the integration side of things. So you need to think about like how do you sort of integrate this to like something like Google services, where you can sort of schedule events on your calendar, and or Outlook, and how do you do that? So it is straightforward to do, but technically, if you are new to the field, it could take a bit of time. So if you can build something like this, and if it can be multi-tenant, where other users can use this product, and this is deployed in a safe way on something like AWS, that could be a really good example to show that you can build sort of systems like this. The key metrics I would say would be around successful booking rate, and if there are clarifications done, like what's the frequency of that, Similarly, like if there are user corrections, and drop-off rate to ensure that that system is working properly. So there are two things to sort of look at this. Obviously, the quality of the voice agent. So there are like different ways you can measure that around how much so the interaction was successful, and also then there's the integration piece, how well the tool calling from the agent is working properly, where they can easily book calendar events on your calendar. How does the integration work? Does it always work properly with different sort of scenarios? Does the prompt written in a way that it can sort of handle these different scenarios? Because this is a very nuanced problem project to solve. And I think if you can build something like this, it's going to be like a really good example to show that you understand AI engineering in detail, because you're looking at different kinds of model performance, prompt engineering, tool integrations. So you got a lot of things moving here. So this could be a really good project if you're interested in building AI, to show that you understand AI in depth. Yeah, I think so. Looked at like four sort of project, and I want to like try and like sort of go into like why these would signal like your senior capability, right? So you clearly sort of define some sort of problem, whether it's handling these like huge number of calls, handling like large number of invoices, like which are multimodal. You start with the problem, and then you sort of figure out, okay, um, thought about the architecture that is needed to solve this, whether the technical stack or the how to deploy this. So you sort of like figure out all the architecture pieces that is needed to build the system end to end. And so this is not relatively simple if you are a junior engineer or a junior, like a fresh graduate. So this is like relatively 2 to 3 years experience in the industry. So if you can sort of think in these lines, it's going to show a lot of maturity, because you thought about the problem, you thought about the architecture, and then you sort of deploy that and to see where are the issues, where are the limitations, constraints, and you try and sort of sort of revamp the architecture and system to fit to handle those sort of issues that you saw in the live deployment. And you keep track of these evidence as we go, and you sort of have some sort of a dashboard on your side to see how the system works. And those kind of things shows a lot of maturity, like engineering capability, to show that you thought about building a robust system, but also thought about longevity around like sort of measuring the right kind of metrics with tools like Grafana, etc. So, so this is, even though it looks very simple, but to get to here, you generally need like a lot of sort of thought and also like a lot of experience. So that's why like sort of following this step-by-step guide, it's going to help you a lot to build like really good sort of solutions. Um, 30-day build timeline. Yeah, Kimberly, I think exactly, very, very similar, Kimberly. Yeah. Um, so 30-day build timeline. So I would say like, because the topic started as like you got 30 days to show your skill set on AI. So you start with like the first week, figure out like some sort of problem, something that you're working on, or somebody else's problem, like you figure out, and like you sort of define what the problem is, what are the success metrics, and then next week you try and sort of define the architecture and sort of refine that with the constraints, and you optimize the system design. So this is where the next steps comes into play. And while you're doing that, start sort of building the system as well. And then third week, you try and deploy this with the right kind of metrics, and make sure that you, if it is not a sensitive topic, publish this information, the code, the README files, and how you sort of somebody else can use this and put it out there. So that's gonna be the next step. And the fourth week, it's about figuring out, depending on the user feedback, if some other people use this, and also different kinds of logs that you get, you fine tune this and make sure that you have optimized sort of the product. And so this is who are is yeah, I built some of those who are is like um what's the sort of the leading question from this? Yeah, feel free to sort of reply. Sorry, I think not during this session, but like happy to go and show like one of these. So yeah, I think like I can show one of those sort of is thought about because um, takes a bit of time to the show, right? So, but yeah, I think we're almost at the end, so I can try and show one of the systems very quickly. Um, so, so what recruiters and leaders infer? So the by doing this, you sort of do the so that you can have like systems thinking, and because we thought about system, how those things work together. And the engineering judgment, like thinking about the constraints, like what are the trade-offs, and how to sort of pick and choose um, the best set of models, the right kind of prompts, and right kind of infrastructure. These are like really thoughtful things that you need to do, and then the production awareness, understanding sort of how systems sort of solve problems, these kind of applications in the real world. It's quite important, and then so that sort of feedbacks into building the right kind of the product, because the right kind of right version of the product, and also making the responsible AI decision making. Obviously, you can talk about ethical, and sort of implementing AI in an ethical way without the potential consequences. So, and this is why important that you write a really good README, as I think Kimberly sort of mentioned early on. So putting this on GitHub, it's going to go a long way. Um, yeah, I think like before we sort of wrap up the slides, and one of the things to sort of remember is that it is not just building something simple enough, and also sort of building something that you have thought through really well, and that sort of shows your sort of engineering capabilities. So if you follow something like Pay's framework, it's going to help you sort of have those right kind of sort of touch points in your project, so that you could sort of try and have it done in a right way. Otherwise, like the time it takes to get to a perfect project is going to take a lot of time. But yeah, I think like that's the sort of the final sort of thought I want like sort of finish this with. But happy to take some questions. In the meantime, I'll sort of show one of the tools, show who are is. Hopefully I'm sort of pronouncing your name correctly. Sorry if I'm pronouncing it wrong. Happy to take any other questions as well. So this is something I built like a couple of days back for another class. So we built this live. So this is like an 18 multi-agent system, relatively simple, but it is sort of built to sort of when you give some sort of a username, like some sort of a client, like it sort of do a deep research and sort of push that information to a Google Sheet. So that's what it does. And let me see if I can find the sheet. Yeah, I think so. I mean, I haven't run this today, but let's see. So I'll sort of let's see if this works. If I say, I don't know, somebody that we all know, so Pichai, and let's see if that works. So what it does is like it sort of do a search and try and do the deep research and push that information to the sheets as well. Um, I think in this one, I think it sort of picked up that information from the model itself. But on the Google Sheet, so I've done these searches before, like this one I did right now. So likewise, so it will start. putting that information to a Google Sheet. So this sheet could be like a table, it could be some other sort of mechanism that like could be SMS or email. It's relatively easy, so you sort of connect this agent to something else. So in this sort of problem, this is just built this out of my sort of interest because whenever I go to client meetings, I would like to understand what my client's background, would love to sort of have some information. So bigger version of this would be like so that I can pull like a lot more information from rather than just what is on the internet. Like there are like services that I can connect to this, but this will do the search for us and then sort of populate that. So every day when this runs, I'll have information about all the clients that I'm talking to the next day on my Google Sheet. I can go and check it out. And sort of relatively, I could have relatively in-depth conversation with those clients. So as you can see, I've thought about the architecture of this, sort of moved on like different kinds of responsibilities that you need, like the deep research agent, like the Google Sheet agent, which is relevant for like handling information with the Google Sheet, and the orchestrate agent that sort of manages the agent, the other agents. So we can add multiple agents to this, sort of creating this sort of. I haven't published this work, but if I write about this, I'm gonna be like the architecture piece, the decisions I made, the models I've chosen, like the models I've chosen is like relatively cheap. Model I have chosen in this mode is expensive node that because you do deep research. So those kind of things are quite important, like having the right kind of structured output because before I store this information in the Google Sheet, I want to make sure that the output is structured in a certain way. So I've set it to like the name, the LinkedIn and description. So you have those information structured so that it won't fail when you start writing to the Google Sheet. So likewise, so I think like you can sort of go into a lot of details and you can collect other resources and do something like that to show that you can sort of build something like this. So this is also not at the production grade level. This can scale up to like 100 plus users, but it like wouldn't handle like tens of thousands of users unless I buy like a very expensive N8N subscription. So that's the downside of this, but this is like a really good way of showing, okay, how agents work, how multi-agent orchestration happens, how do you sort of write prompts, and how do you do tool connections, etc. within a problem like this. So it's just like a very simple example. I think others, some of them are in private repos, on other consultancy work I've done, for example, the multimodal data extraction from invoices. It is some of the consultancy work I've done, so I don't have like sort of a demo that I can show. But happy to go into detail if there are specific questions. Any other questions, guys? More than happy to answer them. Thanks, Mike. Cool, Horace, and thanks for the question. Um, yeah, yeah, Cecilia, you will get the recording, and I'll also make sure that slides are there as well. Yeah. And if you join the WhatsApp group, I'll make sure the slides are shared there as well. Yeah, don't worry. Amazing. Yeah, and thanks a lot for everyone for joining, taking the time and asking questions. Let's keep in touch, and if there are any questions around AI, yeah, to reach out to me on LinkedIn. And yeah, thanks a lot, guys, and see you soon in a very next Lightning Listen. Thanks, Mike. All right. Thank you, Kimberly.